Okay, how do we simplify trig expressions using trig identities? Okay, the first two kinds of identities that we're going to talk about are the reciprocal identities and the quotient identities. These work for any power, but I'll show you that in a second. So, my first reciprocal identity is secant x. So the secant of x is equal to 1 over the cosine of x. The next would be that the cosecant of x is equal to 1 over the sine of x. And the last is the cotangent of x is equal to 1 over the tangent of x. Now, each of these come from, like, this first one, cosine x equals 1 over secant x. The way that we could have gotten back to that point, multiply both sides by cosine, you'd have cosine secant equals 1. Divide each side by secant, cosine equals 1 over secant. So, those identities we knew, now we're just writing them a different way. Secant is 1 over cosine, so on. The quotient identities, that's if we have tangent or cotangent. We're just going to break it down further into just sines and cosines. So the tangent of x is equal to the sine of x over the cosine of x. And the cotangent of x is the cosine of x over the sine of x. As we go through and simplify these identities, you're going to use these quotient identities much more than you'll use this cotangent equals 1 over tan. Because you kind of want to break everything down to sine and cosine. Each of these identities also works for any power. So I could go through and I could say, okay, if it was secant squared x, that's the same thing as 1 over cosine squared x. Cosecant squared x is the same thing as 1 over sine squared x. So we can put these powers on there. So tangent squared x is the same thing as sine squared x over cosine squared x. Cotangent squared x is cosine squared x over sine squared x. And that would work to the third, to the fourth, whatever power. Alright, the next kind of identities are the Pythagorean identities. So here we have a triangle inside of the unit circle, and it's got this degree theta right here. Now, if I were to just try to figure out if I were to use Pythagorean theorem on this, I would say, okay, the two sides squared sum together, so x squared plus y squared equals 1. But then we think back to our Pythagorean, to our trig stuff and our unit circle. For x and y, I know that the cosine of theta is the same thing as x, because the cosine of this angle right here would be this adjacent side over 1. So this is the same thing as just writing cosine theta, sine theta. So using that, if cosine theta is the same thing as x, instead of x squared, I could say that this is cosine squared theta plus sine squared theta equals 1. And this is our first and most important Pythagorean identity. We can take this and we can manipulate the equation. Like if I wanted to solve for cosine squared theta, I could say, okay, then cosine squared theta equals 1 minus sine squared theta. Or the same thing, if I wanted to solve for sine squared theta, that'd be 1 minus the cosine squared theta. I could keep going. I could say negative sine squared theta is equal to cosine squared theta minus 1. Just from subtracting the sine squared theta and subtracting the 1. So you can just keep going and going and going with these. But they're all based on this identity. Now we're going to take that identity and we're going to divide everything by cosine squared theta. So I have the identity cosine squared theta plus sine squared theta equals 1, and I'm going to divide each of those things by cosine squared theta. Cosine squared theta divided by cosine squared theta is 1. Sine squared theta over cosine squared theta is tangent squared theta. And 1 over cosine squared theta is the same thing as secant squared theta. So now I have my next identity. Just like before, we can manipulate this. I could say 1 minus secant squared theta equals negative tan squared theta. Solving for 1 equals secant squared theta minus tangent squared theta, etc. So you just keep manipulating the equation however you want. Okay, now let's go back to this identity and divide them all by sine squared theta. So cosine squared theta plus sine squared theta equals 1, and divide them all by sine squared theta. We would end up with cosine squared theta over sine squared theta is cotangent squared theta plus 1 equals 1 over sine squared theta is cosecant squared theta. So really, cosine squared theta plus sine squared theta equals 1 is the only one that you would really need to memorize. And all of these can be derived from that. So yeah, notice different from the reciprocal and quotient identities that each of these they're always squared. And the way that you're going to recognize when to use these is whenever you see a 1. So just like the other ones, let's just write out a couple more of these. I could solve for, I could say cotangent squared theta, move over this cosecant squared, so minus cosecant squared theta equals negative 1. I could solve for 1. 1 equals cosecant squared theta minus cotangent squared theta, and so on. Just letting you know that these can be manipulated. Alright, so let's use those identities to simplify these trig expressions. The main thing that you want to do is, can I get them down to just sines and cosines? Okay, so cotangent x, in terms of sine and cosine, what is cotangent x the same thing as? It's the cosine x over the sine of x. And this is being multiplied by sine x. Now why would I have wanted to do that? Because now these sine x's cancel. So cotangent x times sine of x is the same thing as cosine x. Alright, so next let's look at the secant of x times the cotangent of x. So the secant of x, in terms of sine and cosine, this is just 1 over the cosine of x. That's being multiplied by the cotangent of x, which is the same thing as cosine of x over the sine of x. So here the cosines cancel each other. I'm left with 1 over sine of x. And what's 1 over sine x? Cosecant of x. Now, I want to simplify 1 minus cosine squared x. So with this one, I have to think, I've got a 1, so it's probably a Pythagorean identity. It also has a cosine squared. So can I use cosine squared x plus sine squared x equals 1? Right? Because this is the identity, and I'm trying to figure out if this can be simplified using this. Well, if I made 1 minus cosine squared out of this, I've got a positive 1. If I just subtract cosine squared from both sides, well, then I would have my 1 minus cosine squared x, and what was left over? Sine squared x. So 1 minus cosine squared x is the same thing as sine squared x. Okay, so for negative cosecant squared x plus 1, I think back to my trig identity of, so whenever I put a star, I'm saying that I'm thinking back, right? Because we're given expressions, not equations. Now, this is an equation, the identity. Cotangent squared theta plus 1 equals cosecant squared. Left off the cosecant squared theta. Okay, now, if this 1 is still positive and this negative cosecant squared, that means that this negative cosecant squared, like, this moved over here. And if there's nothing else there, just negative cosecant squared and 1, this cotangent squared must have changed sides. So negative cosecant squared x plus 1 is the same thing as negative cotangent squared x. Because the expression was given to us in terms of x, I can use my identity in terms of theta, but my answer needs to be in terms of x. Okay, in this last example, we're going to look at 1 plus cotangent squared x divided by 1 minus cosine squared x. So 1 plus cotangent squared x, I look at the Pythagorean identities. That's the same thing as cotangent squared theta plus 1. So this numerator is equal to cosecant squared x over 1 minus cosine squared x. From my first Pythagorean identity, I know that this is sine squared x. Cosecant squared. In terms of sine or cosine, what is cosecant squared x equal to? 1 over sine. Now, since it's squared, this is also squared. Over sine squared x. So now I have a fraction in the numerator. This is pretty much a fraction in the denominator, right? It's just divided by 1. So to get rid of this, I'm going to flip it and multiply. So times 1 over sine squared x. Alright, so now this all equals 1 over sine to the 4th x. So I don't want to have a fraction in my answer. 1 over sine to the 4th, that's the same thing as cosecant to the 4th x. And that'll wrap it up as far as simplifying trig expressions using trig identities.